Hello, College Algebra. I was just about ready to post the solutions to your Chapter P College Algebra Review on page 73. And I realized I do not have the answer key here at home. I started writing it out on a sheet of paper and then figured, oh, why not make this a video and I'll just go through the whole thing with you, and hopefully you can find this helpful. So starting with problem number 4, it says in exercises 4 and 5, evaluate each expression without using a calculator. So the first one is 27 times negative 2/3. I would just cross reduce with the 27 and the 3, multiply 9 times negative 2, which is negative 18, and that was for A. I should label this A. Okay. So for B, we have 5/18 divided by 5/8. Remember that when you divide with fractions, you want to multiply by the reciprocal. So we have 5/18 times the reciprocal, so we're going to multiply by 8/5. Check out that cross-reducing there. Those 5s would cancel out, and the 8 and the 18, we can divide both of those by 2. And multiply straight across, and I think we're at 4/9. For C, we have negative 3/5 raised to the 3rd power. So we're just going to distribute that 3, do negative 3 to the 3rd, 5 to the 3rd. If you take negative 3 and multiply it by itself 3 times, negative 3 times negative 3 is positive 9. Multiply by that, that's negative 27. 5 times 5 is 25, times another 5 is 125. So that one should be negative 27 over 125. For D, we have 3 squared over 2. And we're raising that to the negative 3rd power. So with this one, we want to pass out that exponent to both the top and the bottom. So we have 3 squared to the negative 3rd over 2 to the negative 3rd. And then I like getting rid of the negative exponent. So I'm going to take that 2 to the negative 3rd in the denominator and make that 2 to the 3rd up top, and make this 3 squared to the positive 3rd on the bottom. And 2 to the 3rd, 2 times 2 is 4, 4 times 2 is 8. And with our denominator here, we have 3 squared, which is 9, and then we got to do 9 to the 3rd. So 9 times 9 is 81. And 81 times 9 would be 729, I believe. Final answer is 8 over 729. For E. Oh, there is no 4E. All right, that takes care of number 4. Now we have 5B, which is root 27 over the square root of 2. I would simplify this root 27. So 27 is 9 times 3. And we can square root the 9. That's 3 root 3 over root 2. You're not allowed to have that root 2 in denominator, so we need to rationalize that. Multiply top and bottom by root 2. Root 2 times root 2 is root 4, or just 2. 3 times root 3 times root 2 would be root 6. And then don't forget you have that 3 in front there. Final answer, I have 3 root 6 over 2. Next problem is problem 6a. So on 6a, we have 3z squared times 2z to the 3rd. And we're going to square that. All right, so when we square 2z to the third, it's really 2z to the third times 2z to the third. Let me rewrite the 3z squared out front here. 2z to the third times 2z to the third would be 4z to the sixth. And 3 times 4 is 12. These z's, you would add those exponents in that case. So our final answer will be 12z to the eighth power. Next up, we have 6c. 6c, we have x to the negative second, y squared, all over 3. And then we're going to raise that to the negative first power. There's a couple ways to approach this. One way, we can just distribute this -1 here to all of our factors. So we'll have, when we do that, we're going to multiply the exponents. That's x squared y to the negative second all over 3 to the negative first. The y to the negative second becomes y squared in the denominator. The 3 to the negative first, we're going to use that negative exponent trick, make that a 3 up there, and the x squared is just going to stay. Final answer is 3x squared over y squared. Now we're up to problem 7a. And 7a, we have 9z square root of 8z minus 3 square root of 2z to the third. So when you subtract radicals, you cannot subtract them unless they're like radicals. So this radicand is 8z, this radicand is 2z to the third. So at the moment, we can't subtract these. But what we can do is we can simplify both of those radicals. So the 8z, the 8 is really 4 times 2. So we'll be able to take the square root of 4 and pull that out. And this z to the third, it would be z squared times z. So we can take the square root of z to the second power with that part. So what do we get there? So when we take, so let me write this out. So we have 9z times the root of 4 times 2 and minus 3, 2, and we have, I'll write out all 3 z's multiplied together. Okay, so the square root of 4 right here, that's going to just be 2. And we're going to multiply that by the 9z that's in front. This 2 is still left underneath the radical. And we can take the square root of z squared. That's going to be a single z out front here. And underneath our radical, we still have a 2 and a z. And I just realized I left out this z right here. So let me pull that over. All right, 9 times 2 is 18. So this is 18z root 2z minus 3z root 2z. So this looks difficult, but really if you look at this, this piece and this piece are exactly the same. So you have 18 of these z root 2z's, and you're taking away 3 of these z root 2z's. So when you complete that subtraction, you are going to be left with 15z root 2z. Next up, 7b. Okay, so with 7b, we have 4x to the 3/5 power. And we're going to multiply that by x to the 1/3 power. And the direction is just to simplify the expression. So when you multiply these this x to the 3/5, this x to the 1/3 here, you're going to want to add these exponents, but with fractions, you can't add them unless you have a common denominator. So, well, let's first rewrite it like this. Let's do 4x to the 3/5 plus 1/3. And whenever we add 3/5 plus 1/3, we're going to have to write both of those with a denominator of 15. All right, multiply the top and bottom by 3. 3/5 is 9/15. Multiply top and bottom by 5. 1/3 is 5/15. So add that together. 9/15 and 5/15 would be 14/15. So our final answer will be 4x to the 14/15 power. Next problem is number 8. Okay, number 8, it says write the polynomial x plus 4x to the 4th minus 5 minus 3x squared in standard form. So in standard form, we want to make sure we get our largest exponents, our terms with the largest exponents first. So we have 4x to the 4th minus 3x squared. And then we have plus x minus 5. It also says identify the degree. So our degree is 4. And it also says the leading coefficient. Identify the leading coefficient. This is your leading coefficient. That's also a 4. Next problem, number 10. Number 10, we have x plus root 5 times x minus root 5. So this is a foiling kind of deal. So we're going to take x times x. That's x squared. And if you look at this, when I do my outers and my inners are going to give me negative root 5x. My inners give me positive root 5x. So that's just all going to cancel out. When I take the root 5 times the root 5, that's root 25 or just 5. Make sure you're careful with the signs here. This is a positive times a negative, so we're going to want x squared minus 5. Next up, we have number 11. Number 11, the directions are perform the operation and simplify. We have 8x over x minus 3 and plus 24 over 3 minus x. So remember that you can only add or subtract fractions when the denominators are the same. These are not the same, but they're very close. This has a minus 3, this has a positive 3, this has a positive x, this has a minus x. So they only differ in sign. So what we can do is we can take this fraction and you can multiply the top and the bottom by -1. So this is going to turn into a -24 up there in the numerator. And when we distribute this -1 here, this is going to be -3 plus x. And -3 plus x is the same thing as x minus 3. And now we have that same denominator. 8x plus -24. We don't need to say plus a negative. We can just say 8x minus 24. And our final answer is 8x minus 24 all over x minus 3. Next problem. And we could say here, it says a domain restriction. X can't equal 3. Next problem is number 13. Number 13 says to factor 2x to the 4th. minus 3x to the third minus 2x squared. So first thing you want to do is always check for the common factor, and all of these have an x squared, so we can factor that x squared out. And when we pull that out, we'll have, it's basically dividing each of these by x squared. So we'll have 2x squared minus 3x minus 2. Now, is this factorable? So we pulled out our x squared, and we're left with this 2x squared minus 3x minus 2. Not sure if that's factorable or not. So let's see here. So with the 2x squared, we would want 2x times x. I accidentally almost wrote 2x squared twice there. Okay, so that's what that has to be. Now with the negative 2, you have a couple options here. This could be negative 1 times 2 or positive 1 times negative 2. And then you have to consider that, maybe the minus 1 is over here and the plus 2 is over here, or maybe the minus 1 is over here and the plus 2 is here. Now I know that this one's not right, because if this were the case, you could pull out a 2, and we can't pull out a 2 from this, so I can tell you that's wrong already. And now let's use the positive 1 and the negative 2. So we have 2x plus 1 and x minus 2, or we have, once again, same idea with the, you can't have 2x minus 2 here. Just to finish it up. So this one's definitely wrong. So we're only left with these two as possibilities. Now, do either of these give us negative 3x? This one here with the outers and the inners would give us positive 3x. Close. This one here, though, negative 2 times positive 2 would give me negative 4x plus the x. This is our winner. So our final answer will be x squared times 2x plus 1, x minus 2. I'm just going to do a quick check here, make sure this is right. Yeah, this is good. Number 14b. All right, so 14, actually 13 has two parts. I apologize. This was part A of 13. I need to do part B of 13. So 13b, we have to factor x cubed plus 2x squared minus 4x minus 8. So with this one, you got 4 terms. This makes me think of a factoring by grouping kind of deal. So what I can do here is I can pull out an x squared from this group here, and this becomes just x plus 2. I got to be careful with this minus sign here. So when I group these together, I need to change this sign. So that's minus 4x plus 8. And we can pull out a 4. And when you factor out a 4 from 4x plus 8, you'll have x plus 2. And let's pull out these x plus 2s. And what we're left with, after pulling out x plus 2 from this first piece here, we have x squared. When pulling out x plus 2 from this, we have minus 4. Be careful not to stop there. X squared minus 4 is factorable. That's a difference of 2 squares. This will be x plus 2, x minus 2. And that will take care of 13b. Next problem's 14b. We have to rationalize the denominator. And our problem is 6 over 1 minus root 3. So to rationalize this denominator, you have to multiply by the conjugate. The conjugate, you just change this minus sign to a plus sign. So we need to multiply top and bottom by 1 plus root 3. We have to distribute this 6 up top here, or you can actually just leave it as 6 times this quantity, but I'm going to multiply it out. So we have 6 plus 6 root 3. This is a foiling problem. So 1 times 1 is 1. The outers give us root 3. Inners give us negative root 3. Those are going to cancel out. Root 3 times root 3 is root 9, or just 3. So negative times a positive is a negative. 1 minus 3 is negative 2. And I would have been better off leaving that 6 out front because I can simplify this a little bit. 6 and negative 2. 6 divided by negative 2 would be negative 3. So your final answer is negative 3 times the quantity 1 plus root 3. And once again, if you wanted to, you could distribute that negative 3. And this would also be a good answer either way. Negative 3 minus 3 root 3. 15. 3 more to go. Find the domain of 1 minus x over 4 minus x. So whenever you have a fraction, your domain, you can't divide by 0. So we need to find out when does 4 minus x equal 0. And we can just do some quick basic math here. That would happen at x equals 4. So our domain is all real numbers except x equal to 4. Number 16. Multiply. We have y squared plus 8y plus 16 all over 2y minus 4. And we're going to multiply that by 8y minus 16 all over y plus 4 to the third. So first thing you'd want to do is you'd want to factor everything and cancel out as much as possible. So this is already, just y plus 4, y plus 4, y plus 4. We don't really need to do anything with that. 8y minus 16, we can factor out an 8. So that's 8 times the quantity y minus 2. 2y minus 4, we can pull out a 2. 2 times the quantity y minus 2. Y squared plus 8y plus 16, that's a perfect square trinomial. That's y plus 4 times y plus 4, or just the quantity of y plus 4 squared. And then we can see we got a bunch of stuff to cancel out here. Those y minus 2's are gone. This 8 and this 2, you can divide both of those by 2. So we have a 4 and a 1 there. And these are all gone. And there's a 1 left down here. So our final answer will be, we have a 4 on top. Just multiply straight across your numerators. Multiply straight across your denominators. One domain restriction, y is not allowed to equal negative 4 here. So 4 over y plus 4, y is not allowed to equal negative 4. Last problem, number 18. Plot the points negative 2, 5, and 6, 0. Okay, just draw a little coordinate plane here. So negative 2, 5. We're going to go left 2, up 5. So we're somewhere in there. And our second point was 6, 0. So we're just going to go 6 to the right. So we're right there. So let's label these. That's negative 2, 5. And that's 6, 0. So that takes care of the first part. Find the coordinates of the midpoint of the line segment joining the points and the distance between the points. So we want the midpoint and we want the distance of that line segment right there. So with our midpoint, we're going to use our midpoint formula. Add up our x's, divide by 2. Add up our y's and divide by 2. So our x's were negative 2 and 6. Our y's were 5 and 0. And negative 2 plus 6 would be 4. 5 plus 0 is 5. And 4 divided by 2 would be 2. And we can write this in decimal form, I guess, or 5 over 2. You could leave it like that. So it's 2 comma 2.5. So our midpoint is right here. That's the 2 comma 2.5. Last part, the distance. So our distance formula, x sub 2 minus x sub 1, that quantity squared, y sub 2 minus y1 squared, and plug in your values. Subtracting your x's, you'll have 6 minus negative 2 squared. Subtracting your y's, we have 0 minus 5 squared. Yeah, we got to do the square root of that. 6 minus negative 2, that's the same as 6 plus 2, so that's 8 squared, plus negative 5 squared. 8 squared is 64. Negative 5 squared is 25. 64 and 25 would be root 89. Don't think you can simplify that. Final answer is root 89.